So here we go again. I know this thing certainly equals 0 when x is 0, and this one will equal 0, looks like when x is 2/3. Lovely. So, yes, okay. And so now you're gonna, and we want it to equal 0, so I'll go ahead and put nice and solid dots on those. And I'm going to pick a number, any number I want beyond 2/3, and I can safely say that a billion is bigger than 2/3. So I'm going to plug in a billion. A billion is positive. 2 minus 3 times a billion, 2 minus 3 billion, will certainly be negative. So a positive times a negative will be negative. And then, because these are to odd multiplicities, I'm safe to say that it'll alternate signs after that. You could, if you wanted to, pick a number between 0 and 2/3 and plug it in and see whether it's positive or negative, but I choose not to. I know it's going to work for the reasons I described in the last one, and I just alternate it down. So then I know what's happening to the signs, and I want to know when it's less than or equal to 0, so I want the negatives. So I want all of these x's, any x greater than 2/3, and any x less than 0. So I'll take the x's starting with negative infinity and going to 0, including 0, and unite those with all the x's starting at 2/3 and going to infinity. You'll never have brackets on infinity because you can't equal infinity. And there's your answer. Voila! Now what I should have mentioned on the last graph too is that these beginning ones, if you were to make that an equation, y equals x times 2 minus 3x, and that's 2x minus 3x squared, you'll recognize that graph as an upside down parabola. So it's an upside down parabola with zeros at 0 and 3/2. So upside down parabola, oh wow, look, it's negative over here and negative over here. It all goes together. It's awesome. Okay, and we'll keep picking up steam. So that's that one.